let's look at one last example from this section. Let's discuss the existence of the limit as x goes to 0 of 1 over x squared. So again, we're going to look at this graphically. We're going to look at our function 1 over x squared and graph this function. So if we graph this function, you should be getting a graph that looks like it's got two parts like that, and then like this. So let's look. As I approach, I'm taking the limit as x goes to 0. So we're going to look at the left of 0 and the right of 0. Let's start with to the left of 0. To the left of 0, what happens to my y values? Well, if I look at my graph here, what happens to my y values? They shoot up and they get really, really large. Right? What happens to the right of 0? As I approach 0 from the right, again, my graph, my y values shoot up and they get really, really large. So I'll say that as x approaches 0 from either the left or the right, f of x, my y values, increase without bound. And we can kind of see that if you take a number within 1/10 of 0, well, when I square it, when I square x, it would be less than 1 over 100th. And I'm going to multiply by 100, divide by x squared, right? And this shows that my function is bigger than 100. My y values are bigger than 100 if I'm within 1/10 of 0. If I get even closer to 0, so if I'm within 1/1000th, you can show, I'm not going to go through this, but you can show that your y value is bigger than a million. So like I said, my function increases without bound. It keeps getting larger and larger and larger. There's no stopping it. So here for this function, f of x does not become arbitrarily close to a single number L as x approaches 0. So this one is kind of different from our other examples. My function, my y values don't get close to a single number. And so because of this, I'm going to say that this limit does not exist. So we've seen a few different examples throughout this section, and I thought I would kind of recap In particular, recap limits that do not exist. When does a limit not exist? So the first case is that f of x approaches a different number from the left and from the right. We saw that in our last video, last examples. Then the second possibility for a limit not existing is that your function either increases or decreases without bound. So we saw that here in our example, it increased without bound. And the third possibility, we're not going to see an example of this, but it could be that your function oscillates between two fixed values. And so that would be another reason that the limit would not exist.